Okay, this video asks us to find the measure of direction angles of a vector if all of those direction angles are equal. Kind of a confusing question, but let's take what we know about direction angles. We know that we can measure them by saying cos theta, or the angle with which that component makes with the x-axis, equals that component of the vector, so I'll say A, over the magnitude of the vector. I'm going to call that capital R for now. And we can do that for all three components, right? So cos, instead of theta, I'll say beta, equals b over the magnitude of our vector, and cos, let's say alpha, equals c over the magnitude of our vector. Now we're told that all the direction angles are equal, so I'm just going to use theta for all of them. And what I'm going to do is I'm calling the components of our vector ABC. I'm going to rename those by rearranging these equations. So r cos theta, I'm just multiplying this r up here, r cos theta equals A. So r cos theta equals all of the components. So our vector is now r cos theta, and r cos theta. Because we know that the angle is the same for all of them. So we're just multiplying r across, and we get the same component for each type. Now let's find the magnitude of this vector. So remember, we've already named the magnitude capital R. So let's find r again by using our magnitude formula, which is the square root of all of the components squared. So it's r cos theta squared plus r cos theta squared plus r cos theta squared. Again, this part's kind of confusing because we've just put this, we basically use the magnitude in two different places, right? We've used it as the denominator for the direction angle, but also in the magnitude formula. If we simplify this, we get r equals the square root of 3r squared cos squared theta. Now, if we bring out the r on the right side, we get r equals r root 3 cos squared theta. The r's can cancel, so we can now say root 3 cos squared theta equals 1. And now we can just simply do cos theta equals plus or minus 1 over root 3. I'm just taking the square root of cos squared theta, but that can be plus or minus, and dividing by the root 3. So if you were to plug cos theta equals positive 1 over root 3, you would get theta equals 55 degrees. And you can either plug in the negative into your calculator and do the inverse cos, or know that the supplementary angle is going to be the other option, so or 180 degrees. So again, a bit of a tricky question, but we're using our two formulas. We know how to set up the formula to find the direction angle, and then we also know our magnitude formula, so we use magnitude in two different places. Hopefully that was helpful. You can always send us more questions, info@arnoldtutoring.com. Thanks.